All right, so this is lab 2. My name is Renato Rojas. My Panther ID is 6186196, and this is class EEL-3110C, group 10.
All right, my name is Alano. We're doing lab 2. My Panther ID is 6306968.
My name is Vaughn Moncrieffe. Panther ID 6264565.
All right, so for this lab 2, the learning objectives were basically to conduct a simulation and compare with the hands-on calculations to ensure that the values matched. Observe fundamental law holds through different types of circuits, and familiarizing to analyze complex circuits through different methods such as mesh current and superposition theorem. Here's activity 1, and we basically have the values for the voltage sources and the resistors here.
To solve this circuit, we chose mesh current method. Pretty much mesh current is based out of KVL, as you can see over here. The very first step is being able to get all the currents all of the closed loops. Over here, it shows that we get current C. Continue moving forward. After solving the problem using addition and elimination method, we get the IA, and then lastly is the IB. Now that we all have the currents, we can now do KCL. Basically, it's the algebraic sum of current entering and leaving a node, and it must be equal to 0. And for this slide, you can see all the equation and how we can get the rest of the current in order for us to move on and do the KVL. With KVL, we use KVL as a method in order to get the voltage drop in all of the individual resistors. The equation that we got, you can see over here on the left side, using KVL, we got 5.42 volts for VR3. Voltage drop for R1 would be 0.420 volts. For resistor 4 will be 7 volts, and voltage drop on resistor 2 is 6.55 volts.
Yes, as we continue with the circuit, from the multisim from the calculation we did and the measurement from the multisim, we see that it matches the calculation where each has the voltage drop or for each resistor. So everything matches in this simulation. Hence the KCL or the loop mesh is coincide with the simulation.
And so another learning objective that we encountered during lab 2 was the superposition theorem. And this theorem basically states that a circuit with multiple voltage and current sources is basically going to equal the sum of the simplified circuits just using one of the sources. So here in the pictures, we can see on the right side, the complete diagram basically has both voltage sources from the diagram on the left, which is shorted on the left side and the right side. So the left diagram basically is equal to the right diagram by the theorem.
All right, forward with the calculation. Pretty much what we did, like Renato was saying, we shorted the first voltage source on the left side, leaving us with only the 12 volt. And we pretty much did the same exact process as we did from the first calculation, where we have to use mesh current method. And here's all the calculation. First loop, second loop, third loop using KVL, and then solve the equation using basic algebra such as addition or elimination method. And here's bottom left is all the currents that I got from, or we got from the equation. Moving forward, again, same exact thing, just like I said from the previous slide. Get all the equation, and then you're gonna get a value for the current. And to conclude those equation, you pretty much have to sum them, just like what Renato is saying. The algebraic sum for the currents that we got from the isolated voltage from the first and the second circuit will equate to here at the bottom, IA, IB, IC, negative 1.12 milliamps, 700 microamps, and negative 2.01 milliamps, which is the same exact values that we got from the first method that we did. This is just saying that to continue continue the rest of the problem, to get the rest of the current and the rest of the voltage drop, we pretty much just did the same thing, KCL, KVL, and that's how you get all the voltage drop, which matches the same values that we got from the very first method that we did.
The conclusion for this simulation that we arrive at is analyzing circuits through different methods and observe that it will yield the same result. The numerical value, in contrast to the simulation, matches theoretical, mathematical, hands-on result using methods that we recently learned.